area for mistakes, like little annoying mistakes, you know, like sign rules or multiplication, or even just adding and subtracting and sign rules, all of those things. So we're going to go a little bit over the study guide. I'm not going to have a question like number 1 or 2 at all on the test, but it's just a reminder, like if you were solving a system of equations, whether it was 2 variables or 3, really, if only the variable term zeroes out, that's a no solution, right? It says a system of equations is considered to have no solution when only the variable terms zero out. So x and y, or x, y, and z, if they were to all zero out, then that would mean it was a no solution. I mean, those lines would be parallel. And a system is considered to have many or infinite solutions when both variable and constant zero out. Remember the y, I already said this one, but kind of went over it. Parallel lines, and then this one means that the equation was the same line. So that's really all I was looking for there, just to kind of remind you what that meant. But if I ask you on the test to solve by graphing, even if you choose the right letter, if you don't do the method, it's not going to be correct. So remember, method is graded. Okay, I cannot stress that enough. Your method is graded on solving systems, just like your method will be graded on solving a quadratic equation. Okay, so number 3 says graph x equals 6. So remember, that's crossing the x-axis at 6. So this is 1, 2, 3, 4, 5. So this line would be this. That is x equals 6, crossing the x-axis at 6. The next one I would put in slope-intercept form before graphing, just because it's way easier, faster than having to do a t-chart and finding values for x and y. I guess the other thing you could do maybe is that x and y intercepts where you plug 0 in. But this is the method I always teach and go over. So we need to know how to put a equation in slope-intercept form anyways. So y equals a negative 1 over 3x minus 3. So remember, once you put this equation in slope-intercept form, we start on the y-axis at 0, negative 3. So that would be right here. And if my slope is negative 1 over 3, that means I'll go down 1 and to the right 3. Down 1 and to the right 3. So I would find a straight edge if you have it, or just draw the straightest line you can. And you can see that they intersect at that point. So that would be at over 6 would be the x coordinate. And then we would go down 1, 2, 3, 4, 5, 6. So down 6. I think it's 5. 1, 2, 3, 4, 5. Down 5. So negative 5. You counted an extra line there. So that system, if you were to plug 6, negative 5 into this equation, it would satisfy it. Obviously, if you plug 6 in for the x, it satisfies that top one. That one's a really quick one to check out bravely if you want. Substitution method is when you have x or y by itself, or you get x or y by itself and you plug it into the other equations, whatever. In this case, y is by itself, so we're going to plug it into the other equations, y. So we have 3x plus 4 times y, and y is a negative 2x plus 9 equals 54. So we need to distribute. We have 3x minus 8x plus 36 equals 54. So we need to combine like terms. So this right here would be a negative 5x. And in the same step, just for time, I'm going to go ahead and move my constant over. So we're going to take 54 minus 36, which is going to be 18. Then we're going to divide by a negative 5. And unfortunately, that doesn't reduce fraction-wise. You could turn it into a decimal, I guess, if you want. It is an ending decimal. I was just checking it to see. But I wouldn't, I would just keep it as a negative 18/5, just because sometimes they don't. And then you need to remember, what do I do if that number doesn't end in a complete whole decimal number, right? So I would just leave it like that and then start plugging it into this equation to go solve for my y. So sometimes you get really ugly answers, and this would be a good example of that. You can type this into your calculator from left to right, which I would, just so I don't have to take time finding common denominators and stuff. Even though you're capable, it'll calculate it for us. So y would be 81/5. So this will be one where definitely you couldn't graph it yourself and find the exact intersection point, but you need to answer it as an ordered pair. So negative 18/5 was my x. 81/5 is my y. Solving the system by elimination, you can eliminate your x's or your y's. It doesn't matter. I know in the notes, I think I probably covered towards the y's often first, but in this one, I'm going to go ahead and just do the x's, because if I just multiply the bottom equation times a -3, then I can eliminate x's. That way I don't have to multiply them both. So that's why I said you definitely have freedom. And I don't know, I think I did do one with an x and one with a y before. But if I only multiply the bottom one times -3, it's, I don't know, sometimes the less you're changing, the better, less room for mistakes. So -3x plus 15y equals a positive 39. And so we wanted to eliminate x's. That's why I highlighted it, to draw our eyes' attention to. That's what I'm trying to get rid of. And now we can combine 4 and 15 make 19y, and -20 and 39 make a 19. So this one's a nice y equals a whole number kind of answer. So y equals 1. And then we're going to plug that in for y and solve for x in either equation. Maybe you want to do the bottom equation. You could do the top equation. I know I did that a lot of times in the notes, but like I said, just showing you that you have all kinds of freedom in this. So x minus 5 times 1 equals -13. So you'd have to take 5 times 1, which is just 5, and then add 5 over. So x equals a -8. So ordered pair, I know we solved for x second, but it gets written first. And so the solution to the system, you probably could graph it and see, maybe if if your lines are perfect, but the system to this is, the solution to this system is -8,1. Now, sometimes we're given a problem like this and we want to overcomplicate it. Remember, when we are solving by the elimination method, technically they already give it to us in step 2. You guys remember we kind of went through steps. So like in our notes, I'm going to try to go find one so that I can show you. In our notes, when we were given an equation, a lot of times, most of the time, you do have all 3 equations have x, y, and z, or maybe just one doesn't have like y or something, but you still have a place for all your x, y, and z. So if that was the case, we had to make a 4th and 5th equation to go solve, but thankfully this problem in the review is already down to having 2 equations that only have 2 variables. So it's kind of like you already have a 4th and 5th in a sense, right? So you're just going to solve for that, solve the equation using that equation 2 and 3, because you already have 2 equations that just have 2 variables. Okay, so we're going to work with equation 2 and 3. Just put that 4 and 5 there to say that's kind of like your 4th and 5th equation. already set up for you, given to you in a really nice, handy way. So 2y minus 3z equals a negative 31. 3y plus 2z equals negative 1. Since it doesn't seem like z or y is necessarily any easier, since my z already has opposite signs, I'm picking to eliminate z's. So I'm going to multiply the top equation times 2 and the bottom times 3. So 2y times 2 is 4y. 2 times a negative 3 is a negative 6z. And then we have a negative 62. Then we have here 9y plus 6z equals a negative 3. So we did eliminate those z's. 9 and 4 make 13y equals a negative 65. So we need to divide by 13 to find the y value. So y would be 65 divided by 13 is a 5, and it's negative, so negative 5. So once we know one of the values, we can stick with equation 2 and 3 to go find the other value. So I'm just going to say maybe 2y minus 3z equals negative 31. You could have used the bottom one if you wanted. And go solve. So 2 times negative 5 minus 3z equals negative 31. So we would have to multiply before we move anything over. So we have negative 10. So I don't know why I did that. Sorry. Wouldn't even be writing minus 10 over there, would I? Okay. So I shouldn't have put that line there, but I did. So now I can add 10 to move it. So I have a negative 3z equals a negative 21. Then we divide by that negative 3. So z equals 7. So once you know 2 of the 3 values, you can go by find the third. We have to plug it into the top one because it's the only one with all variables. So I'm kind of running out of space. I'm going to do it over here. So I have 2x minus y plus z equals 24. And I know y and z. So 2x minus, and my y is a negative 5, plus z is 7 equals 24. So double negative means that's really positive. So I'm really just combining 5 and 7, make a positive 12. And then subtract 12. So we have 2x equals 12. So x is 6. So when we write our answer, we have to write it as an ordered triplet. So 6, negative 5, and 7. Turning the page, we learned about nonlinear systems. So like this one would be an example of a parabola. And then this would be like an example of a straight line. Actually, this would be like a circle example because it has a y squared. So what I would do, because this is a straight line and this is some other shape, it's not a straight line, definitely you would want to be using substitution. So I'm going to get y by itself. And that's really quick and easy here because we would just be subtracting 3x to the other side. So I'm going to take that 3x minus 20 and plug it into the other equation's y. So we have x squared minus 9x plus a negative 3x plus 20 squared minus or equals 49. So this could be like a graph like that probably or something. Okay, it's going to have 2 intersection points. We have to FOIL our binomial, so we're going to need to expand it. So negative 3x plus 20 times negative 3x plus 20 equals 49. And I just continue to rewrite what's in front. That way I don't forget that it's there. So negative 3x times negative 3x is a positive 9x squared. Negative 3 times 20 is a negative 60x. We get another negative 60x. We get a positive 400 equals 49. So now we have a few things we can do. We need to combine like terms here, 10x squared, and then we have x terms that could combine. So they're all negative, so that'd be a negative 129. And then because of space, I'm going to go ahead and just show that I'm getting this in standard form, all in the same step, if that's okay. But we're taking 400 minus 49 and getting everything to the same side, and that'd be a positive 351. Okay, so we have put this in standard form, and now we're going to have to factor. Now, it's going to be a really big number that we're going to have to look at if you're factoring this by slide and divide, which is the method we know to use when we have a coefficient here. There wasn't a GCF. It is going to be a big number, okay? But we can still work through it. So x squared minus 129 plus 3,510. And so if we are trying to make a negative 129, does anybody already know the factors for that by chance? Just, have you done this one? So we could start listing them. I'm kind of doing them in my calculator right now. So like I know, for instance, 15 times 234 is that one. Remember, we're using same sign, so that's not going to work. And you couldn't divide it by 25. Well, what could we divide it by? $45 and 78. And so that's not going to work. I've already done this one before, but I don't remember the factors. Take some time. 29. Let's think about numbers that make 29. Actually used to doing this one more like trial and error. Check. Gonna be between. Not gonna be that one. Okay, so I cheated and I did it by trial and error. So that I could figure out what the factors are. So 39 times 90. Okay, that's a long one. I wasn't going through every single one. Obviously, I was skipping around more than I should have. That's probably why I didn't get there. So x minus 39 and x minus 90 equals 0. So then we would divide by our 10. Okay. And so this doesn't go into 39 evenly, so we'd have 10x minus 39. And then here, this would reduce to x minus 9. And so we finally found our factors. So then you would set those equal to 0 and solve for x. So 10x minus 39 equals 0, x minus 9 equals 0. So this would be x equals 39 over 10, and this one would be 9. Okay, so then you'd have to find your y values, and so you just plug them in. Because of time, I'm just gonna stop there today, okay? I spent too long trying to do slide and divide with that big number. Remember, it would have been way quicker if I just would have went through every factor. But I guess I was being stubborn, so I didn't, and it took me a while. But you need to go find your y values by plugging it into any equation. I would plug it into this one, and then you would have your two ordered paired solutions. So we'll take a look at the rest of this. Review a little bit on Wednesday. Wednesday is gonna only be like a review day. So I would highly recommend making sure you had your unit 2 review that we've already kind of looked at together, and this one as well. Maybe have your unit quiz from unit 2 written work with you. I might pick from some of those and just try to do some extra problems to review overall for the proctored test that will have unit 2 and unit 3, because really the only thing we haven't done as a review in this one were Kramer's rule, which we learned today, and then just a repeat of one of those word problems that we were given when we use that tic-tac-toe to find our 2 linear equations to solve it. So I'm going to stop there today. Remember, you do have some assignment. You have an assignment due tonight. It'll be that Kramer's rule assignment Wednesday night. You have, and I'll send out the assignment reminder right after class. I haven't done this week's reminder, so maybe just take a look at that to be totally up to date on what's due. But Wednesday is when your unit quiz will be due, so make sure you set aside time to do it. It would actually be really cool if you could do it prior to Wednesday, because that will help us a little bit more in the review process for your proctored test that's on Friday. All right, guys, have a good day.